Hi everyone. I'm sorry if there's any dog barking in the background. My dog, she's very kind of talkative, so if she wants me to throw a ball for her, she's gonna come up and start barking a little bit. So I'm sorry about that. What we're gonna be doing today, I'm gonna break this up into two parts like I've been doing. I don't want to make gigantic long videos. Today, what we're gonna be talking about is geometric sequences and series. So one of the big things that we're gonna be picking up today is how to find a summation. You've already seen geometric sequences. This is where you have a common ratio where you multiply the initial term by a common ratio. Today what we're going to be going over is kind of a review up until we get over to the sum. So the first thing is this first part, we're finding the common ratio, writing out terms, finding the formula for it. That's going to be something that you guys have seen. That's more of a review. So the first video is going to be on that. The second video is going to be on the new material. So what we're going to do is I'm just going to jump right on into it. The first thing is we're going to talk about what a geometric sequence is, just a little bit more. A geometric sequence is a sequence in which each term after the first term is obtained by multiplying the preceding term by a fixed non-constant or non-zero constant. This is called the common ratio. Okay, so what we're going to do is take a look at each of these and just determine what we're multiplying in each term. One of the easiest ways to find your common ratio is you take your second term and divide it by your first term. So this is your second term and you're dividing it by your first term. Okay, so when you do this, you're essentially taking 5 and divided by 1, and that will give us a common ratio. The other way you can think about it is what did you need to multiply each of these by to get to the next one? We're multiplying by 5 in each. If you guys look at this last one, we're instead of multiplying by a whole number, we're multiplying by a fraction or dividing. And what you guys should notice here is the sign is changing. So when we're dividing here, or when we're multiplying by a fraction, it's going to be a negative. And since 9, how do we get from 9 to 3? We're dividing by 3, so it's the same as multiplying by negative 1/3. And if you guys think about that, 1/3 of 3 is going to be 1. So we're multiplying by negative 1/3 once again, and so on and so forth. So sometimes you're going to see where you're going to have a common ratio that's going to be a fraction, where it could be negative, where it could be a whole number. So the first couple of things you guys are going to see are items that you guys have and we'll be revisiting once again. So the first one, it says write the first 6 terms. Write the first 6 terms of the geometric sequence with the first term 6 and the common ratio 3. So we know we have the first term is 6 and the common ratio is 1/3. So the way we do this is we're going to start out with 6. We're finding 6 terms. We already have 1. So then we're going to multiply this by 1/3. Okay, so essentially we're taking 6 and we're dividing it by 3. So when we do this, we're going to get 2. And then when we do that again, it's essentially we're taking 2 times 1/3 again, and we're going to get 2/3. And then when you take 2/3 and multiply it by 1/3, you get 2/9. And so on and so forth. What you guys are going to start to see is in this denominator, there's going to be a pattern. Since we're multiplying by 1/3, we're multiplying the denominator by 3, so we're going to get 2/27. Then 2/81. This is going to be term 1, 2, 3, 4, 5, 6. Okay. What I'd like you guys to do is please go ahead and do checkpoint 1 for me. I'm going to give you guys a moment, go ahead and pause it, and go ahead and do checkpoint 1 for me. All right, from there what's going to happen is we're going to go ahead and go on and we're going to talk about using the general terms. So with this, essentially, how we determine each of the different parts inside of it is we're taking our initial and we're multiplying it by our common ratio. So here we're multiplying by r once, and then when we're going from here to here, we're multiplying by r again, and that's where we get the squared. And then we're multiplying by r again, this is where we get our third. And then we're multiplying by r again, and that's where we get our fourth. And so on and so forth. Okay. What's going to happen is we are going to extend this idea to where n, or where r, we're going to multiply it by infinite times. Okay. So that's something we're going to get to. We're going to see when a summation is going to converge and when it's not going to converge today. So with this, we actually can come up with a general formula to find that term. And the way we do it is if you're trying to find term 3, you multiply it by r 3 times. If you're trying to find your 6th term, you're going to multiply it by n minus 1 right here as well. So with that, our nth term, we can find it by using this formula where a sub 1 is our initial term and r is our common ratio. Okay, so that's how that works. So what we're going to do is we're going to go ahead and take a look at example number 2. Riley, stop. All right, so from that, what's going to happen is we're going to be doing the same exact thing. It says find the 8th term, so we're trying to find a sub n. So we know our form is going to be a sub 1 times r to the power of n minus 1. And the way we can find that 8th term is we're going to take a sub n, or a sub 8. We're going to multiply our first term times our ratio to the power of 8 minus 1. So if we're thinking about it here, when you do this, we essentially are going to take and multiply our initial term by r 7 times. Okay, so the first thing we have to do is we have to go and determine what these are. So our first term is negative 4, so this is a sub 1. And then our common ratio r is going to be 2. Negative 2, excuse me. R equals negative 2. So what we're going to do is go ahead and plug this directly into here, and then we're going to find our 8th term. So we're going to have negative 4 times negative 2 to the power of 7. So when we do this, we have to once again mind our negative. So if you think about it, if you're multiplying negative 2 times itself 7 times, negative times itself is going to give you a positive, and then a negative, and then a positive, and then as you go, since it's odd, we're still going to have a negative here. So we're going to end up with negative 4 times negative, and then 2 times itself 7 times. Well, I know 2 to the power of 6 is going to give me 32. So 2 to the power of 7 has to be 64. Okay? And then when I go from here, what's going to happen is I'm going to find that this 8th term, 4 times 4 is 16, and 4 times 6 is 24, so I'm going to get 256. Now let's think about our signs. What's a negative times a negative? That's going to give me a positive in this case. So my 8th term is going to be 256. Okay. So what I want you guys to do, please go ahead and try out checkpoint number 2 for me. Go ahead and take your time and do it. All right. And for the last checkpoint from this first video, we're going to go ahead and we're going to take a look at example 3. This is where we're going to be taking some census data and we're going to be making a kind of an idea of what's going to happen in the future. But the funny thing is we're in 2020. We're supposed to speculate where it's going to be at. And the kind of cool thing this year is we actually get to see where we're at. This is a census year, if you guys didn't know. Every 10 years we conduct the census to figure out what's going on, what our population looks like, how it's changing. And so specifically when we're looking at this, we have some information that we're going to have to take into consideration. We're taking into consideration geometric population growth. Okay, we're growing exponentially when we're looking at this and we're trying to find a ratio. The table shows the population in the United States in 2000 and 2010 with estimates given by the Census Bureau for 2001 through 2009. Why don't we specifically know what these numbers are? Well, the census is only given every 10 years. So we have 2000, 2010, and everything else in between is going to be speculatory. Okay, and this year we're going to find out what happens in 2020. So what they're going to do is they're going to try to find out what this ratio is, and then they're going to try to make a prediction for the future. So the first thing we're doing says show that the population is increasing geometrically. So the way you determine if the population is increasing geometrically is you have to find a common ratio. So what we're going to do is take our first term. So for A, we're going to take our term 1 or term 2 and divide it by term 1, or a sub 2 divided by a sub 1. And when we do this, we're going to have 284 divided by 281. Okay, and then point 4. And then what's going to happen from there is we're going to take that and we're going to do the same exact thing for our next set and see if we have that same common ratio. So when we do this, we're going to take term 3 and divide it by term 2. And when we do this, we're going to have a sub 3 divided by a sub 2. Okay? And then from this, what's going to happen is we're going to go ahead and divide these. And when we do that, I'm sorry I had to find a calculator. I thought I had it right next to me. So we're going to have 284 divided by 281.4. And we're going to get 1.009. 1.009. Okay? And then we're going to go ahead and do the same thing here. And we're going to take a sub 3, which is 2002, 286.6. And we're going to divide that by 284. So 286.6, 286.6 divided by 284. And we're going to get 1.009 as well. So when we're looking at this, if we're able to do that and extend it for all of these cases and find that these are actually going to be the same value, that means we have what's called a common ratio. So our common ratio is 1.009. Okay, so for part B, it says write a general term for the geometric sequence modeling the population of the United States in millions and years after 1999. So that's where we're going to come up with an a sub n equals a sub 1 times r to the power of n minus 1. So with this, we know what a sub 1 is. It's our first term. That's going to be 281.4. 281.4 times r, which in this case is 1.009 to the power of n minus 1. All right. And now the last thing that we need to do for part C is we need to find out what's going to happen in 2020. So project the U.S. population in millions for 2020. So what's happening is if we're thinking about this, this is our term. If we're thinking about it, 2000 to 2020, how many years is that going to be? Once you figure out how many years that is, you're going to plug that in here, use your calculator, and you're going to go ahead and find your new value. When you're done, please go ahead and look at checkpoint number 3 for me, and please do all of those. If you have any questions, please send me a picture of your work, and then go ahead and send me a question as well to go along with it.